Now let's contrast bus-based coherence with directory-based coherence. In a bus-based coherence scheme, there are three actions that need to be performed every time the coherence protocol is invoked. We need to find out about the state of this block in other caches, we need to locate the other copies, and then we need to communicate with those copies, which means invalidating them or updating them according to what the protocol does. In generic terms, the faulting processor searches for all of those other copies, and then other processors respond to the search and take necessary action. We could think about doing a broadcast in a scalable network as well. The problem is that in a scalable network, you need to send a transaction directly to the processor that you're interested in, and that would mean you had to perform at least P network transactions for every fault. In the diagram here, we see that the least scalable approach is a Snoopy bus protocol. More scalable would be a Snoopy point-to-point protocol, where transactions were sent to every place on the network. But better than that is a directory protocol. It's a point-to-point protocol based upon a directory. We don't want to have to broadcast to every processor in the system when there's a fault, so we create a directory that keeps copies. So we create a directory that keeps track of where all copies of a block are in the system. Then, when a fault occurs, we know which caches are sharing the block, so we can send invalidation requests individually to all sharers. You might think this is really slow, but it's not so bad because most blocks aren't shared very heavily unless they're read-only. If a read-write block were shared heavily, just as on a bus-based system, there would be a lot of transactions to keep the coherence up to date, and that would be very expensive, so we wouldn't write a program that way. We'd reorganize the program to diminish the level of sharing, for example, by using reduction variables. One example of a recent system that uses directory-based coherence is SGI's Altix system. It's commonly used with distributed shared memory multiprocessors, which are called DSMs, and it can scale to hundreds of processors or actually even thousands of processors.